Physical properties of carboxylic acids, boiling point. The boiling point of carboxylic acids are much higher than those of hydrocarbons and somewhat higher than those of aldehydes, ketones, and even alcohols of comparable molecular mass. This means that carboxylic acids form stronger intermolecular hydrogen bonds than alcohols. Alcohols can form hydrogen bonds, so they boil at high temperature. But now I am telling that carboxylic acids boil at higher temperature than alcohols. Means carboxylic acids form stronger hydrogen bonding than alcohols. Then, what is the reason there? As compared to alcohols, let us see two reasons why carboxylic acids form stronger hydrogen bond than alcohols. As compared to alcohols, OH bond in carboxylic acid is more polarized. The OH bond in carboxylic acids is more polarized. What is the reason there? There is strong electron withdrawing carbonyl group. There is, because of the strong electron withdrawing carbonyl group along with OH in carboxylic acids, the OH in carboxylic acid is more polarized. So it forms a strong hydrogen bonding. Now let us see the second reason. Now if you see, the negatively polarized oxygen atom of carbonyl group also can form hydrogen bond. Means RC double bond OH. This is one carboxylic acid. Let us take another carboxylic acid. Generally, this hydrogen only can form hydrogen bond. But this carbonyl oxygen also can form hydrogen bond. So what happens? This carbonyl oxygen will form hydrogen bond with this hydrogen, and this hydrogen will form hydrogen bond with this oxygen. So the negatively polarized oxygen atom of carbonyl group can also form hydrogen bond with positively polarized hydrogen atom. Or in simple words, the carbonyl oxygen can also form bond with hydrogen atom. So these hydrogen bonds are so strong that they are not even broken in the vapor phase. So in vapor phase and in aprotic solvents, most of the carboxylic acids exist as dimers. They exist as cyclic dimers like this. They may ask, why why carboxylic acids in the vapor phase and in aprotic solvents exist as dimers? This is because of two strong hydrogen bonding. Means two molecules of acids are held together by two strong hydrogen bonding. So they exist as cyclic dimers. That is why carboxylic acids boil at high temperature and exist as cyclic dimers, because of two strong intermolecular hydrogen bonding.